All right, guys. So we're going to go ahead and take the second part of the 8-5 notes. If you started your if you started your Math Excel for this, you would have seen some questions that kind of look like this: a fraction over a fraction. So, anyways, we've kind of seen some problems like what we see up at the top in example 1. So let's just start there. This is kind of a review of what we covered, or part of what we covered in 8-4, where you divide a fraction by a fraction. So I guess just kind of jumping right to it. Well, I guess our learning target is that we want to be able to simplify complex fractions. So the big, I guess the most fundamental thing to understand is that, and sorry that these notes are kind of hard to read, but biggest thing to understand is that this problem right here could be written as 9 over xy divided by x over 5, right? That's, I think it's obvious when we write it out that that's what it means, but a lot of times we just forget. When it's written out like that, it looks like an 8-4 example. So then we remember that to divide by a fraction means to multiply by its reciprocal. So that's kind of how we handle that. So we would just change that to 9 over xy times 5 over x. Look to cross cancel if we can. We can't here. So then we just multiply straight across. And we get 45 over x times y, or x squared y. Okay, and then I guess the last kind of point I would make here is that, remember, when we're dividing by a fraction, we kind of consider 3 out of the 4 expressions as far as what the restrictions would be. So this would be a good reminder too, that we take restrictions from these 3. Okay, they're all kind of technically under a fraction bar. So anything that makes any of those equal to 0 would be considered a restriction. So in this case, that would be x can't be 0 and y can't be 0. All right, so let me do one more that requires some factoring, and then I'm going to have you guys do a couple on your own or with a partner. So looking over at B, we will go ahead and let's go ahead and do the kind of the same change flip part first. So write this as x squared minus 81 over 3x multiplied by 8 over x plus 9. And really, once you get pretty good at these, I'd probably go ahead and factor on this step too, just to save yourself a little time. But we want to kind of show, I guess, a little bit more detail when we're doing notes, so you can look back and kind of see clearly the steps we took. All right, so at this point, we can try to reduce before we multiply, which would, like I said, require some factoring. So the top or the left numerator is going to be difference of squares. So that's going to be x minus 9 times x plus 9. So we have that multiplied by 8 over 3x multiplied by x plus 9. And then we see we do have that common factor of x plus 9 over x plus 9. So we can go ahead and reduce that way by canceling those out. And what we end up with is 8 times x minus 9. So I think I've kind of waffled back and forth, like, can you leave your answer as 8 times x minus 9, or do you multiply? Let me just go ahead and give you a final answer for on that. For your final answer, you want to just have it multiplied all the way out, okay? So let's go ahead and just distribute that 8 and write it as 8x minus 72 over 3x. Okay, and then as far as the restrictions go, remember we want to kind of look at all those. All right, so we would say, you know, from here, x can't be 0. From here, x can't be -9. So 0 or -9 would be my restrictions. Everybody with me? Anybody have any questions? Yes. So remember, we're just using we basically set any of the things that I circled equal to 0, right? And so if you set 3x equal to 0, you get x equals 0. So that means that you know, basically if I plug 0 in for x, it's gonna make that denominator equal to 0, which would give us an error, right? And then same thing with this one. X plus 9 equals 0 gives me the -9. Does that make sense? All right, very good. Okay, so essentially it's the same thing as you know, using the zero product property when we're trying to find the x-intercepts on like quadratic. Okay. All right. I want you, and feel free to work with a partner here to work for the next 5 minutes to try to do C and D, or at least get as far as you can. Okay. And if you're just really having trouble, you can grab me if you need to. But I want you guys to see, you know, are we running into anything that's difficult? Sometimes it's hard to tell when you just watch me work them out on the board. All right, a couple more seconds. Feel free to compare. All right, it looks like you guys are pretty well done. So I'm gonna go ahead and start calling on folks. And if I'm gonna kind of just show the answer, but if you would like to see more detail, then feel free to ask to see that. So Paul Amer, did you get anywhere on C as far as the final answer? Amer, you there? All right. How about Patrick Singh? Did you get anywhere on C? And they say virtual instruction doesn't work. Come on. Claire? No? Chelsea? That's it. 3x minus 3 over 5x plus 5. Good job. What about the restrictions? Did you come up with those, you think, or? Nailed it. Very good. X can't be positive or negative 1, or we could say plus or minus 1. That is the exact right answer. Very good. Okay. And then looking at D, Madison, S. Did you get anywhere on that one?
I think it's wrong. I'll say it.
Oh, come on. Have some faith.
I got X plus 3 over 3.
Okay, yeah, that you've made some mistakes somewhere. That's all right though. Chase?
3x minus 9 over x plus 3.
Let me see. 3x minus 9 over x minus 3. Okay, so I will say that I believe that is... No, that is not correct. Sorry. Never mind. Let me try one more, and then we might go to a volunteer. Looks like I probably need to show both of these, though. Jacobson?
I got 3 over x minus 3.
There it is. That's our winner. Winner, winner, chicken dinner. You just got to be a Dolphins fan to get that one right, I think. 3 over x minus 3. And do you know the restrictions? That's one of the two. It's also negative 3. All right, so those are just the answers. It looks like we probably need to spend a little bit of time going over how to get there, okay, based on, what we just saw there. So anyways, looking at C, no factoring or anything involved. So you just want to do same change flip. So you go 3 over x plus 1 times x minus 1 over 5, and then you just multiply straight across. So 3 times x minus 1 is that, and 5 times x plus 1 is that. As far as the restrictions go, we kind of look from here down, right? So anything with a variable, you're setting equal to 0. X plus 1 equals 0 gives me negative 1. X minus 1 equals 0 gives me x can't be positive 1. Okay. Next one's a little bit more difficult because it requires some factoring. So let's look at that real quick. All right, so I'm going to do a couple things in this step. First, I'm going to do same change flip, but I'm also going to factor anything that could be factored. So the same part would be the x plus 3 over x minus 3. change it to multiplication, and then do the reciprocal, right? So this is going to be my numerator, and I'm going to factor it out because I can factor out a 3. So I'm going to write that as 3 times the quantity x minus 3. And then this is going to be my denominator because I'm multiplying by the reciprocal, and that's a difference of squares, so that'd be x plus 3 times x minus 3. And then we're multiplying straight across after we reduce, okay? So x plus 3 cancels with x plus 3. X minus 3 cancels with x minus 3. And what we're left with is 3 over x minus 3, which you can see is our answer. As far as the restrictions go, we're looking from, again, here down. So if you set all those equal to 0, you either get positive or negative 3 for all of them, okay? So hopefully that helps. Anybody have any questions after that? Oh, man, came all apart on me. It all moved together. Now it came apart. Jeez. All right. Anyways, there you go. Okay. So let's go ahead and so you might wonder, like, why is this in 8.5 and not 8.4? So it's because of these. For some reason, this is called example 3. It's actually our second example. So example 2. So it's because we really can't do anything with A as is, and I know it's kind of hard to see on your notes and really even on the board, but it says 3 over 5 plus 2x over 1/2 minus 6 over x. So unless we know how to add or subtract those, we really can't go forward, okay? We can't use same change flip yet. So what we need to be able to do is simplify both of them, all right? So this goes back to yesterday. So simplifying my numerator. So I think about what's my common denominator. It's going to be 5x, okay? So as I work to get my common denominator, then that means I would multiply the 3/5 by x over x, which is just going to give me 3 times x. And then I'd multiply the 2 over x by 5 over 5. So I'd have, so 3 times x plus 2 times 5 over 5x, which would just simplify to 3x plus 10 over 5x. And then we'll do the same thing with this. Yeah, so we'll have 1 times x minus 6 times 2 over 2x. So that simplifies to x minus 12 over 2x. So at that point, then, all we've done is really simplified the numerator and the denominator. All right, so so now we're thinking, you know, it's just really this fraction over this fraction, and then it's like example 1 from there, okay? So after that, you just do same change flip. So that'd be 3x plus 10 over 5x times 2x over x minus 12. And then we could multiply straight across, but we do have a common factor, so I'm going to go ahead and reduce that out. So x over x is just going to be 1. So now I will go ahead and multiply straight across, and that should be my final answer. So 2 times 3x plus 10 is going to give me 6x plus 20. And then 5 times x minus 12 will give me 5x minus 60. So that is my reduced answer. And again, as far as my restrictions go, I kind of think back to the original. And I'm looking at, you know, the second, third, and fourth levels down, right? So all of this, anything that would make those denominators equal to 0. Or it might be easier to look in our, let me actually change where I highlight that. might be easier to think about our reduced fractions, right? So kind of looking here, here, and here, right? So, you know, if I set the 5x equal to 0, I get 0. Set x minus 12 equal to 0, I get 12. Set 2x equal to 0, I get 0. So my restrictions overall are 0 and 12. But x can't be 0 or 12. All right. So any questions on that? So just one extra step with those when you have the addition or subtraction. And I'll have you guys finish up by doing B. So just do your best there, and we'll go over it here in just a sec. Actually, 186. Move that out of the way so you virtual kiddos can see it. All right, so just to kind of, I wanted to give you guys a little bit of work time, so just to save a little bit of time, does anybody want to try to volunteer the answer? Anybody pretty sure you got it? Chase? 3x over, and now I'm calling on you, and I realize I don't even have it written down, so I forgot I have to work this one out, so we'll find out at the end. I think that might be right. So sorry about that. All right. So here is basically how this one would go. So we want to change this to kind of a simplified fraction up top. So that would be when I add them, I get 3x plus 7w over w times x, or just wx. And that's over 3w, sorry, let's go 7x minus 3w over wx. All right, so at that point, you're ready to kind of multiply by the reciprocal. So that's going to be, make sure I don't run out of room there. So that'd be 3x plus 7w over wx times wx over 7x minus 3w. So the wx's are going to cancel each other out to be 1 over 1. And then so what we're left with is 3x plus 7w over 7x minus 3w, which is what Chase said, right? Something like that?
No.
You should have just said yes. You should have just said yes there. But yeah, that would be it. As far as our restrictions go, we are looking there. So so anything that you know, anything that makes those equal to 0. So that would be where. So when you have that double, you know, when you have that double variable thing on those, you know, it's easier just to really look here and here. But my restrictions would just be that w or x can't be 0. Okay, w can't be 0, x can't be 0. All right. Does anybody have any questions about any of those steps while I'm recording here? All right. Okay. Well, I'm going to go ahead and stop the recording then. And if you want to take a little break, you can. We have about 13 minutes, but you should be able to at least knock some Math Excel problems off your plate in that time. Let me know if I can help.